Hi guys! Today I'm just going to be reviewing what we know so far about finding the area of a parallelogram or a triangle or a trapezoid, and then I'm going to talk a little bit about how to find area of irregular figures at the end. There's no form to fill out for this video, so I just want you to bring notes about finding the area of these different types of figures to class, and then also there will be a problem at the end that I'm going to ask you to find the solution of, and I'd like you to bring that to class as well. Here we have a parallelogram, and remember that we can find area of a parallelogram by just multiplying the base times the height. And so the important thing to be able to find on a parallelogram is to understand what the base and the height are. Remember that we cut apart some parallelograms, and we noticed that you can always take any parallelogram and cut it apart and rearrange the pieces of the parallelogram and make them into a rectangle. And when we find area of a rectangle, we do the length of the rectangle times the width of the rectangle. Or you can think of it as the base, the bottom edge, times the height. And so notice that when I moved this side of the parallelogram over to form that rectangle, my height did not change. It didn't get any taller, it didn't get any shorter. So the height of the rectangle and the height of the parallelogram are exactly the same. So that's why it's important when I'm measuring the height to make sure that the base and the height form a right angle. They have to be perpendicular to each other. So remember, when you're measuring on a parallelogram, the height always needs to be at a right angle to the base, which means we cannot use this side over here as my height. And then the base, you can use any of the sides of the parallelogram. So if I were to turn this parallelogram so it was sitting on the short side, that would be fine. I would just be measuring a taller height that way. I can measure the bottom edge here with my ruler, and I can see that it's right around 14 centimeters in length there on the base. So I could label my base as 14 centimeters, and I'm going to multiply that by whatever the height is. And it looks like the height is right about 7.5 centimeters. If I round a little bit, it's pretty close to 7.5. So I would need to take that base length and multiply it by the height, and that would give me the area of this parallelogram. So that comes out to be exactly 105 when I multiply those two together. And it's very important now to think about what the label should be. I measured both the base and the height in centimeters, so that means that the little squares that I would be covering the inside of my parallelogram with would be also have sides a length of a centimeter. So if my lengths are in centimeters, then when I'm measuring area, my unit is square centimeters. For a triangle, we can also pretty easily see the formula. Any triangle that I take, if I make an exact copy of that, so now I have two congruent triangles, and I turn this one over, I can always take any triangle, make a copy of it, and put those two together to form some type of parallelogram. It might be a rectangle, it might be a square, but it will always be some type of parallelogram. So you can see these two come together and form what looks like a square. I'd have to measure the sides to be sure, but it's definitely a rectangle if nothing else. These two triangles over here, if I take a congruent copy and put those together, you can see that they form a parallelogram. And the same thing would work with the triangle down at the bottom. So when I'm looking at the formula, I can remember for any parallelogram, so if I was to find the area of this entire parallelogram that I formed with those two triangles, my area would be base times height. But I don't want the entire parallelogram, I only want the area of the triangle, because that's really all I'm finding the area of. So I am going to take half of that, because these two triangles are exactly equal, so the area of one is just going to be half of the area of that total parallelogram. And you can think of that as multiplying by 1/2 or dividing by 2. Those are the same thing. Again, be careful with a triangle. When you're measuring base and height, the base needs to be one of the sides. So this is probably important information to write in your notes, just like it was for a parallelogram. The base can be any one of the sides of the triangle, just like we said for the parallelogram. And then the height, again, needs to go from the tallest point to the lowest point and needs to be perpendicular to the base. So if I look at this triangle down here at the bottom, if I'm using this side right here as the base, then my height needs to go all the way from the very highest point down to the base, and it needs to be perpendicular to that base. And there's no way I can draw a line through this triangle that's just going to be inside the triangle that will make a right angle with the base and go from the highest point to the lowest point. I would go from that very highest point all the way down to the base, making sure that my height line forms a right angle. So when I measure my base, I'm still going to only measure the length of that side. So it's going to go from here to here. I'm not going to measure this part that I extended out. This was just to help me find a right angle. Then my height would be from here down to the level of the base, which is why I extended that line out. So this would be my height line, and then my base would just be that side of the triangle. It's a little bit confusing sometimes when we have an obtuse triangle. So if you are the one doing the measuring, sometimes it's easier just to turn your paper so that it's sitting on its longest side. Then I can draw a height line through the triangle from the highest point to the lowest point that would be forming a right angle with the base. So it would go all the way from the top down to the bottom and form a right angle with the base. So I would measure this for my height and this for my base. For a trapezoid, just remember the activity that we did. So I can again take a trapezoid and I can turn it on its head or make a copy of it. So now I have two congruent trapezoids, and turn one over and put them together, and they will again always make a parallelogram. So whatever the area of this parallelogram is, the area of that trapezoid will be half of that. So we're going to use that information. Again, my height did not change when I put those two together like that. Remembering that area of a parallelogram is base times height, I'm going to do the base times the height. But here, my base, this big long base, is formed by looking at the top base and adding that to the length of the bottom base. So we call one of those base 1 and the other one base 2, and it does not matter which is which, but I need to add my two bases together. And it's very important when you're dealing with trapezoids that the two parallel sides are always used as the bases. No matter which way the trapezoid is sitting, we're going to use the two parallel sides as the base. And then again, my height has to be perpendicular to that base. So my height didn't change when I made this parallelogram. My base is this big long side down here, so I have to add my two bases together. And then remember that I just want the area of one of those trapezoids. So I am going to multiply this again by a half, or you can think of it as dividing by 2. So this is my formula for the area of a trapezoid. My last example here is an irregular figure. When I find the area of an irregular figure, I'm going to divide it up into parts that I already know how to find area of, and then I'm just going to add all those areas together. So you can see this crazy figure right here can be divided up into a trapezoid over here on the side, a rectangle in the middle, and then a big triangle over here. So go ahead and pause the video now and figure out the area of this large figure, and we will talk about this at the beginning of class. So once you've figured out the area, you can unpause the video and be done, and just make sure you bring your notes and your solution to this problem to class. Thank you.